Hello, welcome to Using Synthetic Division to Calculate Limits. This is Brian Isley. You might remember me from such movies as The Empire Strikes Back or E.T. Extra Tarea. That's homework in Spanish. Anyway, we are here to use some synthetic division so we can get at this factoring. Because when I look at this problem that you see on your screen, it's not a limit, of course, but I do want to factor it. And the goal to factoring this really comes down to knowing one of the roots, one of the numbers that makes this function equal 0. So I happen to know one, and that number is -2. So when x equals -2, this function equals 0. So backing up a bit, if I add 2 to both sides of my x equals -2, I get x plus 2 equals 0. Now that tells me that when x equals -2, that I must have had a factor of x plus 2 in my polynomial right here. So hidden inside there is a factor of x plus 2. And that's why when I put -2 into this polynomial, I get back 0. So that's why the power of synthetic division is going to help us out here. I'm going to factor this by starting with my synthetic division box. So remember, you put the opposite of what the factor is, so -2 inside. I have 1x cubed plus 4x squared minus 11x minus 30. Okay, here we go. So just doing synthetic division, 1, and then you multiply by -2, -2, add 2. Multiply by -2, -4, add -15. Multiply by -2, and I get positive 30, add, and I get 0. So using synthetic division, I can see that I had a factor of x plus 2 in there because my remainder is 0. So one factor is x plus 2, and from synthetic division, I have the other factor is x squared plus 2x minus 15. Okay, let's do some limits. When I see a limit like that, don't feel sick. I used to feel sick. Don't you feel sick? You look at it and say, oh my gosh, I don't know. What do I got to do? Well, the problem is you can't just plug in 3 because technically x doesn't equal 3. And I know you'd like to plug in 3 to get a limit, but x can't just plug in 3 because 3 might make the denominator equal 0. And I don't know about you, but I don't look forward to plugging 3 in for x, cubing it, timesing by 2, and then squaring it, multiplying by -7, then adding those two things together. I don't look forward to doing that. But what I could do is just plug it in using synthetic division. So remember, I'm thinking that if 3 makes this polynomial in the denominator equal 0, that it must have a factor of x minus 3 in it. So 3 then would go in my box, just like it is in the limit right there. And then I have 2x cubed minus 7x squared plus 2x plus 3. And you must account for every power of x, which we did. So dropping down the 2, I get 3 times 2 is 6. Add -7. Oh, -1. I can't add. Let's see, the next one. 3 times -1, that gives me -3. Add those two together and I get -1. 3 times -1 is -3. Add them together and we got 0. That's fantastic because now we know that 3 makes this thing equal 0 because synthetic division is actually the same thing as plugging 3 in. But regardless, we also know that one factor of the denominator is x minus 3 because we got a remainder of 0. The other factor of the denominator is 2x squared. See where I'm getting that from my synthetic division? Minus 1x, so right there, then minus 1 right there. There we go. So that's the denominator. And I see that I have a factor of x minus 3. The thing with limits is I'd like to plug that 3 in to get my limit, but I can't because 3 makes this denominator 0. And a 0 denominator is undefined. So let's check and see if that 3 is in the numerator. So I'm going to do this again. I'll do it in red. So I have 3 for the numerator, and I'm going to plug it into 3x cubed minus 2x squared minus 17x minus 12. Let's see what we get. So, drop in my first 3 there. 3 times 3 is 9. Add them together and I get 7. 3 times 7 is 21. Add them together and I get 4. 3 times 4 is 12. Look at that. Add them together and I get 0. So I have a factor in the numerator of x minus 3. And from my synthetic division then, I have 3x squared plus 7x plus 4. Now let's put this all together, all back together. So this limit, in strong hands, you must always write limit until you actually take the limit. So x approaches 3. In the numerator, now with my new factored form, I have x minus 3. So that factor was there. And then I have, pulling it from the red here, right? 3x squared. And then I have plus 7x. And then I have plus 4. Nice. On the bottom, pulling it from the blue over here, I have another factor of x minus 3. That's good. And then I have the rest of that, right? 2x squared minus 1x minus 1. There we go. Look at that. Top and bottom. They're all multiplied. I have factors. Can I cancel? And make my giant 1. There we go. Now, when you make your giant 1 and you don't have a lot of room, don't make it too long, okay? Like I did. So, now I'm going to take the limit, which means I don't have to write limit anymore. So I'm just going to plug in 3. So plugging in 3 to the top, and I might make some little notations up here, gives me 3 squared times 3, which is 27, plus 3 times 7, 21, plus 4. So 20 plus 20 is 40, and 7 plus 1 is 8. So 48 plus 4 gives me 52. So I'm going to write that right there, 52. Now the denominator, plugging in 3, gives me 9 times 2, which is 18, minus 3 minus 1. 18 take away 3 is 15, minus 1 is 14. So 52 fourteenths, which we could make better by dividing out 2 as 26 sevenths. And there you go. Use synthetic division to help you factor, to help you find the thing that causes you to be undefined, so you can get rid of it, plug in your number you're taking the limit for, and finish up, right? Thank you for listening. Good luck.